Hello, my name is Alper Kanak from Ererge. Today, I will briefly explain our hardware-based security solutions in critical change project jointly with my colleague Gertjan from IMEC. As we all know, fintech infrastructures are getting more vulnerable to cyber attacks, especially in the last decade. Many banks and financial institutions have been attacked. Such attacks can be high-level as software-based threats, which are developed by attackers as malicious pieces of code. On the other hand, low-level attacks deal with hardware-based components as they pertain to access tokens, network infrastructures, and even industrial control systems. Thus, we can easily say that systems will get more vulnerable as they evolve from cyber to cyber-physical when more complex and heterogeneous systems take place. That's why we need point-to-point holistic security in such cyber-physical systems. Trusted authentication and cryptographic schemes are indispensable to holistically improve the security of a cyber-physical system. For instance, authentication as a service is one of the critical change innovations, enabling the person and node authentication. However, we need more to protect data in financial infrastructures. According to Kershoff, a crypto system cannot be accepted as secure if the cryptographic keys are predictable. Existing software-based pseudo-random number generators are predictable, and famous hardware-based solutions like physical unclonable functions usually do not provide dynamic secret generation. We propose the effective use of hardware security modules, HSMs for short, which are less vulnerable to attacks. We integrate IoT-enabled hardware-based security solutions with service-oriented software-based tools for more holistic and better cyber-physical protection in critical chains. Our hardware-based solutions are threefolded: authentication as a service, hardware security as a service, and cryptography or crypto as a service. We combine these technologies for person and node authentication, more trusted IoT applications with secure distance bounding, and HSMs for more effective and secure encryption and data protection in financial infrastructures. In critical chains, hardware security as a service is developed at FPGA level as an hardware security module operating at the server side. It relies on two alternative designs of hardware-based true random number generators. Hardware security as a service enables the low-level cryptographic functions like symmetric and asymmetric encryption, hashing, and crypto key generation. The underlying research has been finalized by prototyping either lower cost or higher throughput true random number generators, like reconfigurable true random number generators based on transient effects of ring oscillators and chaotic oscillators, respectively. The crypto as a service is a high-level software service which enables the basic cryptographic functions. Crypto as a service enables the fast encryption of any financial transaction, data on transit, or data on storage. Crypto as a service is based on a service-oriented architecture and on-demand ready service whenever needed or called by other X as a services. Crypto as a service joins the works with the hardware security as a service that enables prime number and crypto key generation, secure key storage and exchange, symmetric and asymmetric crypto functions, which are all compliant with the public key cryptographic standards. Before handing over to Gertjan to learn more about secure distance bounding and authentication as a service, let's have a look at our short video about the crypto as a service and hardware security as a service achievements.
Hello, I am Gertjan. I'm pleased to present our contribution to the Authentication as a Service. Okay, now, here we go. The hardware solution presented now is made for Authentication as a Service, which is the secure stick. The secure stick is FIDO compliant. Two versions are made of the secure stick. One version has a USB interface, the other has a wireless interface. The wireless interface needs a secure node authentication. The secure authentication of the wireless link is done by secure distance bounding. Distance bounding means that when two wireless nodes are within a certain distance from each other, the two nodes are allowed to communicate. As shown here in the pictures on the right bottom. In the left picture, the person is far from the car. The light is red, which means the person is out of range of the car and the car cannot be opened. When the person is close to the car, the light is green, which means the person is in range and the opening of the car is allowed. The secure distance bounding is done in 3 phases. Phase 1, the preliminary authentication. This is the key exchange between the two nodes to make sure they are allowed to do distance bounding. Phase 2, the actual distance bounding. This is the phase where the distance is measured. The measuring is done with a certain amount of encrypted data transfers between the two nodes. Phase 3, the final authentication and authorization. In this phase, it is determined if the nodes are within a certain distance. In other words, if one node is within the trusted circle of the other node. When one node is within the trusted circle of the other node, the wireless link can be trusted and used for data communications. With this algorithm, the secure distance bounding adds an extra layer of security to the wireless link and prevents impersonation attack, range extender attack, early detect, late commit attack. The developed technologies and the background knowledge integrated in critical change have a high potential to be exploited for commercial benefits. The background knowledge can be exploited by an advisory service. The developed technologies like the secure stick, the hardware as a service, the cryptography as a service, or the secure distance bounding can be exploited either via a solution delivery service or via a licensing and royalty service. If you want more information on the presented subjects and beyond, you can follow the links provided on the bottom of this slide.